Greetings to the respected faculty. I am Lasya Mandapati from CSC AI&ML B section. My roll number is 24951A6686. And today, for the complex engineering problem of the course Computer Networks, I'll be presenting on the topic Types of Computer Networks, LAN, MAN, and WAN. This topic is a fundamental concept in computer networks. It also plays a crucial role in how modern communication systems are designed and implemented. Over the course of this presentation, I will walk you through what computer networks are, how they are classified based on their geographic coverage, and the key differences between LAN, MAN, and WAN. By the end, you'll have a clear understanding on how these network types function and where they're applied in the real world systems. Before we begin, here's a quick overview of what I'll be covering. We'll start with a brief abstract and introduction to computer networks, followed by how networks are classified based on geographic coverage. Then we'll go into detail about local area networks or LAN, metropolitan area networks or MAN, and then wide area networks or WAN. After that, we'll compare them, explore other types of networks, and look at real world applications. Finally, we'll cover network devices and topologies, followed by results, summaries, and conclusions. This structure will help us move from basic concepts to more practical understanding. Computer networks can be classified in many ways, but one of the most important classifications is based on the geographical area that they cover. The three primary types under this classification are LAN, MAN, and WAN. Each of these networks differ in size, speed, ownership, and complexity. In this presentation, we aim to understand how these networks function and where they are used. This is important because choosing the right type of network directly impacts performance, cost, and scalability. Understanding these differences allows engineers and organizations to design efficient and reliable network systems. A computer network is essentially a system of interconnected devices such as computers, servers, routers, and other hardware that communicate with each other. These devices share data, resources, and services. Communication in networks is made possible using protocols such as TCP or IP, which define how data is transmitted and received. Networks can use wired connections like Ethernet or wireless technologies like Wi Fi. Additionally, network devices such as switches, routers, and access points ensure smooth and efficient communication. Networks are classified based on size, purpose, technology. But today, we focus specifically on the classification based on geographic coverage. Networks can be categorized based on the area they cover. At the smallest level, we have PLAN, which connects personal devices. Then comes LAN, which covers buildings or campuses. Next is MAN, which spans across cities. And finally, we have WAN, which covers countries or entire globe. An important point is to note that larger networks are built by connecting smaller ones. For example, multiple LANs can form a MAN, and multiple MANs can form a WAN. As the network size increases, complexity increases, costs increase, and speed will also decrease. This is why different network types are suited for different applications. A local area network, or LAN, is used to connect devices within a small area, such as a home, office, school, or campus. LANs are typically privately owned, which makes them easier to manage and secure. They offer high speed, low latency, which makes them ideal for file sharing, internet communication, and shared printers and servers. LANs commonly use technologies like Ethernet and Wi Fi. In terms of topology, modern LANs mostly use a star structure where all devices are connected through a central switch. This improves performance and makes troubleshooting much easier. A metropolitan area network, or MAN, covers a large area. typically a city or metropolitan region. WANs are found by connecting multiple LANs using high speed technologies such as fiber optics, microwave links, etc. They're commonly used by internet service providers, government networks, or large organizations. MANs acts as a bridge between LAN and WAN. They provide moderate to high speed, wider coverage than LAN. However, compared to LAN, they are more expensive and more complex to maintain. Not only this, but they also may face issues like network congestion and security challenges. A wide area network or WAN spans a very large geographical area, such as countries, continents, or even the entire world. The best example of a WAN is the internet. WANs connect multiple LANs and WANs using leased lines, satellites, or even public network infrastructure. They are essential for global communication, cloud computing, and online services. However, due to long distances, speed is lower compared to LANs and latency is higher. Also, WANs rely heavily on router and advanced protocol like IP and VPNs. They ensure reliable data transmission across large distances. Let us now compare these three network types. First, in terms of coverage, LAN covers small areas, WAN covers cities, and WAN covers global regions. Second, in terms of speed and latency, LAN is the fastest and with lowest latency. WAN is moderate, and WAN is slower with higher latency. Third, in terms of cost and ownership, LAN is usually private owned and low cost. WAN can be public or privately owned and is moderately expensive, whereas WAN is the most expensive as well as complex. These differences help determine which network type is best suited for a particular application. Apart from a LAN, WAN, and WAN, there are other types of networks as well. For example, PAN, a personal area network used for devices like smartphones and Bluetooth. WLAN, a wireless local area network, which is essentially a wireless version of LAN, and many more like SAN, which stands for Storage Area Network. These networks are designed for specific use cases, especially where mobility and convenience are important. They complement the main network types and are often integrated into larger systems. Now, each network type has its own applications. For example, LAN is used in offices, schools, and computer labs, whereas WAN is used for citywide connectivity, university campuses, and municipal Wi Fi. Similarly, WAN is used for the internet, global business operations, global communications, cloud computing, and cloud services. These applications show how networks are essential in both everyday life and in large scale systems as well. To make these networks function, we use various devices such as hubs, switches, routers, access points, and modems. Each device has a specific role. For example, switches are common in LANs, routers are commonly used in WANs. In terms of topology, LANs usually use star topology, whereas MAN and WAN use mesh or hierarchical structures. Modern networks often combine both wired and wireless technologies to achieve better performance, flexibility, and wider coverage. To summarize, LANs are best for high speed communication in smaller areas. WANs provide MANs provide connectivity across cities, whereas WANs enable global communication. Each network type has its own advantages and limitations. Understanding these helps in designing efficient network systems. In conclusion, understanding LAN, MAN, and WAN is essential for selecting the right network type based on performance, cost, and complexity. In real world scenarios where networks are often a combination of all three types, this classification also provides a strong foundation for academic learning, network design, as well as practical implementation. Thank you for your time and attention. I hope this presentation has helped you gain a clear understanding of different types of computer networks. Thank you.